Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. Today we will discuss about another descriptive statistical tool, geometric mean. Geometric mean is usually used to compute the average percentage change in a particular variable over time. And geometric mean is simply the nth root of the multiplication of the n number of data items in the data set, which is given in this formulation. Geometric mean is equal to nth root of the n number of data items, where x1 define first data item, x2 define second data item, x3 define third data item, and so on. Xn define the nth number of data item of the data set. Geometric mean is the nth root of the multiplication of the n number of data items. So from this formulation, students, this is very clear that all the data items are in multiplication form. We will multiply all the data items and then we will compute its nth root, where n define the sample size, that how many data items data set carry. Let me introduce another terminology that will help statistician to compute the geometric mean, that is growth factor. So what is growth factor? Growth factor is equal to 1 plus I over 100, where I over 100 represent the percentage change over time in the particular variable. So it's mean I over 100 define the percentage changes over time in the particular variable. And what is growth factor? Statistician will develop growth factor simply by adding 1 to the given percentage changes over time. I'm putting one note that statistician will use few steps to compute the average percentage change in a variable over time using statistical tool geometric mean. The steps are as given below. In the very first step, statistician has to develop the growth factors simply by adding 1 to the given percentage changes over time. So I'm reading this first step, develop growth factors by adding 1 to the percentage change in the variable over time. Second step, compute the nth root of the given growth factors. When statistician develop the growth factors, in the next step statistician will compute its nth root to define the geometric mean value. And the third step, compute the percentage change in the variable over time simply by subtracting 1 from the computed geometric mean or nth root value of the growth factors. In the third step, when statistician define the nth root, statistician has to subtract 1 from this geometric mean value and define the average percentage change in the particular variable over time. Let me clarify this concept of geometric mean by putting one example. Compute the average percentage change in the annual expenditures of the transport department of Salam University over time. The percentage changes in the annual expenditures of the transport department are as given: 10% increase in expenditures, 15% increase, 25% increase, 10% decrease in expenditures, and again 5% increase. All those values which are positive, it define increase in expenditures annually, and the values which are negative, it show decrease in the annual expenditures of the transport department of Salam University. I'm putting one note that statistician will use geometric mean as a statistical tool to compute the average percentage change in the annual expenditures of the transport department of Salam University. So statistician has to follow the 3 steps. In the very first step, statistician has to develop the growth factors, and simply by adding 1 to the every percentage change in expenditures over time. So step 1, develop growth factors. I am using x1 as a symbol to represent the first data item. The first data item of the data set is 10% increase in annual expenditures. So to define the growth factor, statistician has to add simply 1 to this percentage change. So x1 is equal to 1 plus 10%. This is the first growth factor. X2 define the second data item simply by adding 1 to develop the growth factor. So 1 plus 15%, where 15% is the percentage increase in the annual expenditures of the transport department at Salam University. To define the growth factor simply by adding 1 to this percentage change, we have x2 is equal to 1 plus 15%. A third data item, third growth factor x3, by adding simply 1 to the third percentage change, the third data item, which is 25%. So 1 plus 25%, this is the third growth factor. And again the fourth growth factor by adding 1 to the minus 10%, 1 plus minus 10%. And the fifth growth factor x5 is equal to, by simply adding 1 to the 5%, 1 plus 5%. I am again repeating, statistician has to develop the growth factors simply by adding 1 to the all percentage changes over time in a particular variable. Now x1 is equal to 8, these two terms 1 plus 10%, we can write 0.10 also. x2 is equal to 15%, we can write 0.15. x3 is equal to 25%, we can write 0.25. x4 minus 10%, we can write minus 0.10, and the last one 5%, we can write 0.05% as well. So we will add all these terms and we will define the 5 different growth factors for the given data set. So x1, the first data item, adding these two terms 1 plus 0.10, we have 1.10. Again second data item, by adding these two terms, 1 by adding 1 with 0.15, we have 1.15. Third data item, by adding these two terms 1 plus 0.25, we have 1.25. And fourth data item, by adding 1 with minus 0.10, we have 0.90. And the fifth data item, by simply adding these two terms 1 plus 5%, which is 1.05. So in the very first step, simply by adding 1, statistician has to develop the growth factors. Now we will put all these growth factors in the geometric mean formulation to calculate the nth root of the 5 different growth factors. So geometric mean formulation, standard form, nth root of the 5 different data items x1, x2, x3, x4 and x5, where n is 5 mean the sample size is 5. Data set include 5 data items. So we substitute the growth factors in here: 1.10, 1.15, 1.25, 0.90, 1.05. I am again repeating that we will put all the values of x1, x2, x3, x4 and x5 in this standard geometric mean formulation, and we will calculate its fifth root. To be continued. Geometric mean is equal to n is 5, and these are all the 5 growth factors. When we multiply 5 different growth factors, we find the value 1.4942, and in the step 2, statistician has to compute the fifth root. We have the fifth root of this 1.4942 is 1.2223. This is the geometric mean that statistician calculate by taking the fifth root of the given data set. Now in the third step is we study that to compute the percentage change in the expenditures, annual expenditures over time, simply statistician has to subtract 1 from the computed geometric mean value. So geometric mean value is 1.2223. In the third step, statistician has to subtract 1 from this geometric mean value, and percentage change in the annual expenditures of the Salam Transport Department of Salam University is 0.2223 or 22.23%. So this is the percentage change, average percentage change over time in the expenditures of the Transport Department of Salam University, 22.23%. What does this mean? What is the interpretation? Interpretation is this, that the annual transport expenditures of the Salam University are increasing by 22.23%. Simply we can say that the transport department transport expenditure of the Salam University are annually increasing by 22.23%. I am again repeating interpretation of this average percentage change in annual expenditure is this, that the annual transport expenditures of the Salam University are increasing by 22.23%. Interpretation: the expenditures are changing by the average amount 0.2223 or 22.23% over time per period. I am again repeating that the transport department expenditures per year of the Salam University are increasing by 22.23%. Now to further clarify, I am putting one another example. For example, if annual increase in prices is 10%, 3%, 2%, 4%, 20% over time, compute the annual average percentage change in prices over time. In this example, we are calculating the average percentage change in the prices of the goods and services over time. So again, statistician has to develop the growth factors. That is very first step. How statistician can develop the growth factors? Simply by adding 1 to the given percentage changes in prices. So step 1, develop growth factors. X1, define the first data item of the data set simply by adding 1 to the given percentage change in prices at first year, 1 plus 10%. This is the first growth factor. X2, define the second data item simply by adding 1 to the 3%. This is the second growth factor, 1 plus 3%. X3, define the third data item of the data set simply by adding 1 to the 2% to develop the growth factor. So X3 is equal to 1 plus 2%. 4% is the fourth data item. X4 represent fourth data item. To develop the growth factor for the fourth data item, simply statistician will add 1 to the 4%, 1 plus 4%. X5, define the fifth data item. Again, to define the growth factor, simply statistician has to add 1 to the 20% increase in price. We have X5 is equal to 1 plus 20%. I am again repeating, in the very first step, statistician has to develop the growth factors. How? Simply by adding 1 to the percentage change in prices as we develop the 5 different growth factors. Now to be continued. X1, we add here this 1 plus 10% is 1.10, 1 plus 3% is 1.03, 1 plus 2% is 1.02, 1 plus 4% is 1.04, and 1 plus 20% is 1.20. And now we write here, this is the first growth factor 1.10, second growth factor 1.03, third growth factor 1.02, fourth growth factor 1.04. This is writing mistake. This is not 0.04, this is 1.04, because to develop the growth factor, statistician has to add 1 to the percentage change. In here percentage change is 4%, but 1 is missing, so when we add 1 to the 4%, it will be 1.04, not 0.04, and X5 is 1.20. Now put all the growth factor values in the geometric mean formula as given below. Geometric mean, the fifth root, because we have 5 different growth factors, we will multiply all the 5 growth factors. 1.10 multiplied by 1.03 multiplied by 1.02, 1.04 and multiplied by 1.20. When we multiply these 5 growth factors, we find the value 1.4422, and now in the second step we will compute geometric mean value by taking its fifth root. So step 2, taking the fifth root of the 5 different growth factors we have. Geometric mean is 1.2009, and the third step to calculate the percentage change in the annual expenditures prices over time, we have to subtract 1 from the geometric mean value. So percentage change, when we subtract 1 from the 1.2009, 1.2009 minus 1 is equal to 0.2009 or 22.09%. I am again repeating from here. This is the calculated nth root value of the 5 growth factor. This is the geometric mean value. Now to calculate the percentage change in prices over time, statistician has to subtract 1 from the calculated geometric mean value. Calculated geometric mean value is 1.2009. Subtract 1 from this, we have the average percentage change 0.2009 or 22.09%. What does this mean? This means the prices annually are increasing by 22.09%.